linked list implementation of stacks. Okay. Right. In array implementation, we are saying that we are fixing it to some number like this. Okay. This is a drawback in array implementation, that the size cannot be increased. Okay. So then you can go for dynamic array, but again there what is happening, I am creating an array with S of 5 elements. If I want to add a new element, I have to copy all this, I have to use realloc function and again reallocate maybe some 6 elements. After allocating this, we have to copy these existing 5 elements into the new array. Like this you have to keep doing it always. Okay. So both the approaches have drawback, but they are useful, but anyhow they have drawbacks. Even linked list implementation has drawbacks, right? Why? Unnecessarily I am storing the pointer here. If I want to create 5 elements in a stack, int of 5 is sufficient. Int S of 5 is sufficient for 5 elements in a stack. But if I want 5 elements in using linked list, see, I am storing the data part and the next pointer part. So I need two blocks always. That's always a drawback. But the advantage here over linked list over arrays is that it is expandable. As and when new elements you want to add, you can add it. You want to delete, you can delete it. Okay. So assuming we all know about the linked list implementations, we will see how stack can be implemented using linked list. So you take a case of single linked list. In a single linked list, I have a list like this: 4, 15, 7 and 40. Okay, 40. Right. So what are the two important operations which I want to implement? One is push, other is pop. So where do I have to insert? We know in stacks, if this is a stack, insertion and deletion happen at only one end. So you can implement by making it easy by inserting an element at the beginning and deleting an element at the beginning. Okay. See, push operation is implemented by inserting element at the beginning of the list. Okay. And pop operation is implemented by deleting the node at the beginning. Why? So if this is my linked list, suppose I have 40, 7, 15 and 4. This way it is stored. Okay. We are doing in reverse. You may say, sir, why don't we do that inserting element at the end and deleting element at the end? The time complexity is more if you want to delete and insert at the end, because why it is more? You have to always traverse the list. You have to always traverse the entire list. Okay. So that's a problem here. That's why we are using the linked list, and in that also we are choosing the best operations, that is inserting an element at the beginning, deleting an element at the beginning. So if I insert element at the beginning, I have to do that is push operation, and pop operation can be done by implementing the delete operation at the beginning of the node. So that's it. So list like this. If you want to do pop, 4 will be deleted. If you want to insert something above 4, a new element will be inserted. That is, if I want to put some 5 like this, you can keep adding elements like this. Okay. If you want to delete, you can delete the from the beginning. This also is one kind of implementation of stacks, right? So how do we do this? How to just let's recollect or recall about deleting an element at the beginning and inserting an element at the beginning of a list. Okay. How do you delete and insert elements at the list? So instead of head, now I am taking a pointer top. Head or top, anything is fine. We are maintaining what is top. Top is a pointer which is always pointing to the topmost element of the stack. Okay. So I have a list like this, linked list like this, and my top is pointing at 4. Suppose I want to insert a new element. I want to perform push operation. This is equal to inserting an element at the beginning. Inserting element at the beginning. So how to do? First create a node structure. Let it call as new node. Then put the element 5 and some empty like this. We already know, that's what, assuming that you already know how we are doing the linked list, right? We already have seen about this linked list insertion at the beginning. So you have to create a node like this. insert a value 5, put the next part as null. Then this step is very simple. You need not iterate also, you need not traverse the list. It's very simple point that new node next will be top. New node next will be top. It means where is my top? My top is here. So this arrow mark will go, this null will go, and a link will be created like this. So 5 is attached to 4 now. The next operation what I have to do? I have to make top equal to new node. I have to say top equal to new node. It means I have to delete my top from here, make this as my top. That's it. Very, very simple operation. Inserting an element at the beginning or performing push operation. So this can be considered as stack operation, always inserting. Then on 5 you can put other number, again you can put another number, you can keep inserting it like this. Okay, very simple operation, that is push operation. It is same as inserting an element at the beginning of the list, which is very easy. Step 1 is to declare a new node, put some value in that with null. Then second step, that new node next should point to this top or head in our language of linked list. It should point to top, and then you have to make the new node as the top, because that is the inserted element, and top should be always pointing to the recently inserted element, right. So with these 2 lines you can complete the push operation. What is the next one? That is pop operation. Let's see that, how you perform the pop operation on the linked list. Right. So in pop operation it is equal to same deleting an element at the beginning. So how do I have to delete? So this is my top, take a temporary, you can declare another variable as temp, which is also pointing to the head or the top. After this what I have to do? Simply make your top equal to temp next. Okay. So this will become my top equal to temp next, one statement. Okay, top equal to temp next. So this is my temp, right, and there is this here. Yeah, this is my temp. I am just moving my top to the temp next, means here I am making this as my top variable. After that, that's it. If you want, you can put temp next equal to null, temp next. After this you can put it null, so that this relation is broken, or otherwise without even this you can simply write here free of temp. That's it. So again 2 statements, very simplest implementation. So you see the advantages here with the linked list implementation. Implementing this push and pop operation is very easy. Okay, and what we say, it is expandable, it is dynamic in nature. You can keep adding elements, you can keep deleting elements. Only the smallest drawback what we have is maintaining an additional variable for pointer. Instead of, if I want to store 4 integers, it will take me 4 into 4 bytes, that is 16. But in this case it will take 4 into 8 bytes. So space might occupy, but again since we have all high end systems, that should not be a problem, right. So this is the advantage of linked list implementation of stacks over the arrays and dynamic array. Okay, so it's very simple. We will try to implement this and see how it is done. Let's see the implementation of stacks using linked list. So again, since I am using the C++, I will be using some header file, and see, we are using linked list implementation. So single linked list. So I have to create the node. So with that 2 variables, int data and again struct node star next. Okay, so I created this. Then we used to create head pointer, but here let us take that as top. So struct node star top equal to null initially. Okay, so I will quickly write the int main part. See what I have to implement here. I have to implement push function with some integer int x. That's it. And also I have to implement the pop function. So maybe I want to return the element which I am deleting. So int pop, or we can even print it here itself. void pop, this does not requires any inputs, right? And the third function which I have to implement is display, which also does not requires anything. So here you see I will be pushing 10, then again I will push 20. It is like calling your insert at begin function always, right? Push of 30, then display. I am just writing the skeleton of the program so that you understand what we are trying to do here. Then I will do pop, again display. Okay, till this we will try to see. So you see, in push operation is insert at the beginning. So for that, what you have to do, you have to create a new node always and link it to the existing tree. So for that, struct node star new node is equal to, I hope you remember this, struct node star malloc and size of struct node, right? This way we can allocate memory for that. And then new node data is equal to this x which I am passing as the parameter, this x value which I am passing as the parameter, and new node data, next equal to, anyhow we do not need this, but we will do that on conditional basis, right? So this is the case. Now if the new node, if the top was null, it means if there exists no element in the list, if the list itself is empty, then what we have to do? So that's why I am checking if top is equal to null, then in that case I have to simply say top equal to new node. That's it, top equal to new node. Else part, else what I have to do? I have to write our logic. What is that? New node next is equal to top and top equal to new node, right? So this is the logic of implementing the push operation. I think you are aware of this. In single linked list, these three commands will create a new node with some data and the next pointer as null. If the top value is null, if the top is null, it means there exists no element in the list, then simply make that new node as the top. Okay, else then new node next equal to top and top equal to new node, right? So this way you can say the element is inserted into the linked list or into the stack. Okay, simply we can do it like this, right? Now let's implement pop. What is pop here? I want to delete the element. To delete element, I have to create a temporary pointer, right? So for that, struct node star temp is equal to top. It should point to top. Instead of head, I am writing here top. After this, what I have to do? Once I got the temp, I have to again check. What I have to check? If the node is, if the list is empty, then we cannot delete, right? So that one check we will try to do. So again, if top is equal to null, so you can simply say some message that the list is or the stack is empty. Stack is empty. Some message, anything you can write it here. Otherwise, what I have to do? Else. Otherwise, what I have to do? So when I am deleting, I have to just put my top equal to temp next. So temporary is pointing at the first node. I should move that top from the first node to the next node. Then simply write free of top, free of temp, not top. That temporary pointer will delete. So this is about the pop operation, or indirectly I would say deleting an element at the beginning of the list. Okay. Now let's go for display. To display again, I have to iterate over the entire list. So again I will take a temporary pointer here. So then what we have to do? While temp not equal to null, right? What we have to do? Temp equal to first cout data, cout temp of data. Okay, and we will put end else so that it displays nicely. Then temp equal to temp next. That's it for displaying. That is okay. But again, if you want, again you can put this logic. If top is null, you can directly say stack is empty, otherwise you can display it like this, right. So these three are the functions. If you know how to insert an element at the beginning of the linked list, then that itself is the push operation, and if you know how to delete an element at the beginning, that itself is the pop operation, right. Now let us try to execute this and see whether it is displaying. Okay, let us just add a little flavor to this. Elements in the list in the stack are, then after after doing the pop operation, again if I delete in stack after deletion, right. So let us execute this and see. Oh sorry, I missed return 0, right. So if I execute this, oh malloc, sorry, yes, we have to use the header file cstdlib, sorry, it is cstdlib. Now yeah, it is executing. See, elements in the stack are 30, 20, 10, elements in the stack after deletion 20, 10. I hope this is visible. Right. So this clearly looks like a stack, no? I am putting 10, then on top 20, then on top 30. So it looks like the original stack what we were learning, 10 on top that 20, on top of it 30. After deleting, see the elements in the stack after deletion are 20 and 10. After deleting, let us again try to push some elements. 30 is deleted now, let me add 40 and again push 50. So I am doing this, again I will write these two elements in the stack. Now let us see, so I am adding 10, 20, 30, I am deleting 30, then again I am adding 40, 50, I am displaying it. So if I execute this, yes, see here, it's clearly visible. Elements in the stack are 10, 20, 30, elements in the stack after one deletion is 20, 30, again after adding those 40, 50, it becomes 10, 20, 40, 50, right. So this is the linked list implementation of stack data structure. Okay. So this is widely used because it has, we are facing the problem of limited size in the static array implementation. So we go for this linked list implementation, right. So these are the different ways of implementing stacks using linked list, arrays and dynamic arrays.